Bismillahirrahmanirrahim. In this video, we are going to learn how to evaluate the derivative of a function, definition or ab initio without going into the conceptual details. So suppose we are given a function f of x whose derivative is to be calculated. So first step, we are going to name that function as y equals to f of x. Next step, we are going to give an increment del x to x. Correspondingly, we will get an increment del y in y, or you may say x by x plus del x and y by y plus del y. Next step, we have to find the change in y. So we evaluate this del y by just moving this y towards this side. You can see this is it. Now we are going to put the value of y equals to f of x here. Next, we have got the change in y. Next step, divide both the sides by del x. Here it is. Del y divided by del x, f of x plus del x minus f of x divided by del x. What is the next step? Apply limit when del x tends to 0 on both the sides. This limit is called the derivative of y with respect to x, and this is the derivative of f of x with respect to x. We write it as dy by dx, and we write it as f dash x. So this is the whole procedure of evaluating the derivative of a function by, you may say, by definition, by ab initio, or by first principle. Let's revise. Whenever we are given a function, we will name it y. Next step, we will evaluate y plus del y, and by replacing x by x plus del x. All you have to do, wherever you have x, replace it by x plus del x. Wherever you have y, replace it by y plus del y. Then evaluate del y by moving this y towards this side. Then use the value of y, which is equal to f of x. And after this, you perform simplifications in this step. After that, we divide both the sides by del x. Again, we perform simplifications in this step. And then we apply limit. This limit is called dy by dx, and here to evaluate this limit, we have to use the techniques which we have learned in exercise 1.3. And we evaluate this limit, and this limit is called the derivative of f with respect to x. Let's try to evaluate the derivative of 2x square plus 1. So just observe, we are just going to follow the steps that we discussed in the previous slide. Step number 1, let's name it equals to y. Y equals to 2x square plus 1. Step number 2, we will replace this x by x plus del x, this y by y plus del y. Here it is. You can see we can take a square here. So this is the simplification which we will try here. And also we will bring this y towards this side with a negative sign so that we get the value of del y. Here it is. We have simplified the square, and we have brought the y to this side. What will be our next step? We will put the value of y equals to 2x square plus 1 here. Also, I see that I can open up this bracket. So these are the two things which I am going to do in this step. Here it is. I have opened the bracket and I have put in the value of y, which was 2x square plus 1. Now you can see there was a negative sign, so I have used the bracket. And next step, I will open up this bracket. Let's do it now. You can see I have simplified it. I have opened up this bracket, and now what do I observe? This 2x square got cancelled by this 2x square. This one got cancelled by this one. And I'm left with only these two terms which I have written here. Next step, I see that I can take something common. So what is that something? That something is 2 del x. So I also take that common. Here it is. Now what I see here is that del y has got 4 steps here. Del y evaluated in this step, but for simplifications here I used 4 step. Now I have got del y in its most simplified form. Now I go to the next step, which is divide both the sides by del x. Again I am performing simplification, and here it is simply that I divide these two del x. I cancel these two del x, and I have got this thing, del y by del x. Now what next? Apply the limit. Limit when del x tends to 0. This limit will be written as dy by dx, and this limit we will evaluate it using the techniques which we have learned in exercise 1.3. And what is that? Just put in the value of del x here. Just put a 0 here. You can see it there. Ye dekho. Dy by dx is equal to 2 into 2x plus 0, and the answer is 4x. The derivative of 2x square plus 1 with respect to x at the point x is 4x. Let's go to part 2. The function given here is 2 minus under root x. So I simply start with the same thing. Let y equals to 2 minus under root x. This is my start. Now what I'm going to do, I'm just going to repeat all those steps which we learned in the first slide. And what are those? I will replace this x by x plus del x and y by del y plus del y. Let's try it. Next step, bring this y over here so that you get the value of del y. Here it is. Next step, put the value of y, 2 minus under root x, here, and you can see there is a negative sign outside, so I will use a bracket. Let's see. Here it is. Now I see some simplification that I can open up this bracket, so I am performing that simplification. Now I see that I can cancel these two, so I simply cancel. I'm going to cancel this 2 with this 2, and now then I will have a negative sign in the start, which I don't like, so I'm going to put this under root x over here so that I don't have to start my expression with a negative sign. That is my personal choice, and that also makes our work easy, that we don't start a given expression with a negative sign. So let's see what is my next step. Here it is. 2 has been cancelled, and I have written this under root x over here. Now I don't see any further simplification, so I get to the next step of derivative, and which is divide both the sides by del x. Divide del y by del x, divide this by del x. Here it is. Again, I don't see any simplification, so I'm going up to the next step, and which is apply limit when del x tends to 0. So I apply limit when del x tends to 0. Here I get limit when del x tends to 0. Here I get limit when del x tends to 0. And what do I observe? This limit will be dy by dx. There is no issue with it. It is the definition of derivative. This is the definition of derivative. But in this limit, I observe if I directly apply del x equals to 0, I am going to get 0 by 0 form. And again, we refer to the techniques that we have learned in exercise 1.3. In that exercise, we have been taught that if we have got an expression like this, the easiest way to resolve the problem is to rationalize it. And how do we rationalize? We rationalize by multiplying and dividing by this plus this. Here it is. Here is the step of rationalization. I have multiplied and divided by under root x plus under root x plus del x, under root x plus under root x plus del x. So in the next step, what we will see, this using the formula a minus b into a plus b equals to a square minus b square. What do I do? Here you see. dy by dx is equal to limit when del x tends to 0, under root x square minus under root x plus del x whole square divided by del x, and the denominator here remains the same. It is just lying there, 1 by under root x plus under root x plus del x. We perform this simplification, and what do we see? We get this thing. This radical sign and square are being cancelled, and I have got this. Next step, I open up this bracket and I get this. Now this x and x got cancelled and I get this expression minus del x by del x. Then this del x and del x got cancelled and I get a 1 in place of it. So this is what I get. Limit when del x tends to 0, minus 1 multiplied by 1 by under root x plus under root x plus del x, and now we can apply the limit. So just apply the limit, put del x equals to 0 and you will get the result, which is this. Add it and we have the derivative equals to minus 1 by 2 under root x. Now you see, students, that a lot of steps and simplifications are used here. This is just to make the things clear to you. You can go for shortcuts, you can go for direct results if you can. But I have done all these steps in detail just to make the things clear to you. And this is how we evaluate derivative by definition or by first principle.